So today we are going to look at solutions for exercise 2, that is substitution method, integration by substitution method. So yesterday we looked at the simplifications of simple functions, but now today we are going to look at substitution method of solving integration equations. So you can see this is the exercise in your books or in your solutions. We are going to look at how we are supposed to arrive at all the solution to this one, so that you can be able to compare with what you have solved and found to see if we are going to get the same. So we start with the first one. The first one, we are told to integrate x sine of 2x squared dx. So because we are using substitution method, you have already been given a hint. But remember the fundamental that we said about substitution method. You should look in that function, a function which when you can differentiate will give you another function. For example, if you differentiate x, you are not going to get any function that is here. But if you differentiate this function inside here, you are going to get 4x. So a constant does not bother us. What is important is x. So you can see x and x matches, and so it means they are going to cancel somewhere in the process. So we let u is equals to 2x squared. Then we find the du dx should be 4x dx. This means that we have du over 4x is equals to dx. Then we can do now the substitution. It is we are integrating x sine of the whole of this one we replace with u. Then dx we replace it with what we have found here, du over 4x. Now this one will simplify, x and x will cancel, so we are going to have we integrating sine of u with respect to du, which we all know this one. The integration of sine is minus cosine, so this one will be a quarter. Integration of sine is minus cos u, that way. And now this one can be written as minus 4 cos of u. U we know it is 2x, don't forget to put c, 2x squared plus c, don't forget that. So that is a bit simple. You can be able to see the answer. You can check if you arrived at such an answer. Also, question 2, we are told to integrate sec 2t tan 2t dt. Now there is two ways of doing this question, but I want to do it in the simplest way that can be able to see. So from your SMP tables, you can be able to see this formula. For example, sec of t tan t dt is equals to sec of t plus c. This formula is there in the SMP table. So you can see this is almost similar to this one. The only difference is that here we have t, but here we have 2t. So we can write the substitution, let u is equals to 2t, so that we have du is equals to 2 dt. So that we have du over 2 is equals to dt, that way. So this means now we can do that substitution. We can have, we integrate sec of u tan of u, then this one will be dt, we replace with du over 2. So this one will be a half, integrate a half sec of u tan of u du. We know the integration of this one. We know its integration is sec, so it is secant. So we can write this as secant of u plus c. Now, what is u? We already know what is u, so we can substitute u back. We have u is to t plus c that way. So that one becomes that simple. Also, I said there is another way you can try it. Try this other way. Try to substitute u is equals to secant 2t. This one will give you give you this answer. You are going to arrive at this answer. So try this one. If there is any problem, you can let me know, but it will still give you the same answer. So we have question. So we are told to integrate this one. Also, already we have been given what to substitute. We are told to substitute cos t over 2. That is what we are told to substitute. So we have du over dt. So we know that derivative of 1 is 0. Now we put minus outside. Derivative of cos, it is minus sign. T over 2 multiplied by a half. Remember, the general way to find a derivative of cos, a cos function of the form, is normally you differentiate the outward function, which will give you minus sign. You retain whatever is inside here, then the whole of this you multiply by the inner derivative. So to find the derivative of this one, you multiply by it, which will be m. The same case, derivative of cos is minus sign. Derivative of t over 2 is a half, so we multiply by a half, we get this one. We can now do the substitution, which is u squared. The whole of this one is u squared, sine of t over u, then our du dt becomes, you can be able to look at this one. Our du dt will be 2 over sine t over 2. Very, very simple one. It is just you make dt the subject of the formula. Now this one automatically will give you this one, and this one will cancel, so this one will be u squared du, and this one will give us 2 u over 3. The whole of this we add c, which is the same as 2 over 3. What is our u? Our u is 1 minus cos t over 2. The whole of this is cubed plus c. Don't forget. Question 4 says we integrate the function of this form, 9r squared over square root of 1 minus r cubed. It is easy to see that if you differentiate the numerator, you are going to get 18r. So we don't have any function that corresponds to r. But if you differentiate whatever is inside here, you are going to obtain minus 3r squared. You can see we have r squared, and here we have r squared. So the best substitution will be to let u is equals 1 minus r cubed, so that we get du is equals to minus 3r squared dr that way. So that we have du is equals to minus 3r squared is equals to dr. We can do that substitution. This one will give us, we integrate 9r cubed square root of this, the whole of this is u multiplied by du over minus 3r squared. You can see now we can do some cancellations. We can cancel r and r, and the minus 3 can cancel with 1, and minus 3 we get minus 3. We can do that cancellation. So that now we are going to obtain, which is integrate, we can take 3 outside, so we are going to integrate 1 over square root of u du. Now this one is very easy because this one is you integrate u power minus half du, and this automatically becomes minus 3. Integration of this one will be 2 power half plus u, that way. Now we know what is this one, will be minus 6 minus 3 multiplied by 2 minus 6. Our u is 1 minus r cubed, that way, then plus c, which you can write it in compact form as 1 minus r cubed plus c. They're all the same, they give you the same answer. We can check at question 5 now. Again, this one is a simple one because we can write this integral as x power half sine squared x to 3 power 2 minus 1 dx. So you can be able to see if we differentiate x to power half, we are not going to get a function inside here if we differentiate this. But if we differentiate this function here, we are going to get this function here. So you can write u is equals to 3 power 2 minus 1. So this one will give you du is equals to, this one are going to give us du is equals to 3 over 2 x power half dx. This implies that 2 over 3 du over x power half is equals to dx. We can do that substitution, which is going to give us integrate x power half sine of sine squared of u, then our dx we replace it with 2 over 3 du over x power half. This and this we are going to cancel out. We can take 2 over 3 outside, so we are going to have 2 over 3 integrate sine squared of u with respect to du. Now sine squared of u, remember it can be written as 1 minus cos 2u over 2. Remember we can write it that way, so we are going to write it, so this one is the same as a half minus a half cos of u, this expansion here. So we can replace it that way so that we can do integration. This one will integrate, we are integrating now, we replace this one with this one, a half minus a half cos of 2u sorry, cos of 2u du, and this now give us a very it give us a very one. We integrate a half, this one we are going to get u, we are going to integrate. Remember integration of cos is sine. You integrate cos, you get sine, so this one will be minus a quarter sine of 2. So sorry for that. So this one is 2u, and don't forget to add c. Somebody will ask, where did a quarter came from? You differentiate whatever is in here, you divide by it, so it will be a half multiplied by a half, which will be a quarter. I hope that is clear. It is not that complicated. So when we open the bracket, this one now will give us a very good function, 1 over 3u minus 2 over 12, or I can just simplify, and when I simplify this one by 2, so I have 1 over 6 sine of 2u then plus c. Now I can replace back 1 over 3u. We know our u. What was our u? We have it here, x power 3 minus 1, that was our u, minus 1 over 6 sine of 2 into bracket our u was x3 power 2 minus 1 plus c. That one becomes our answer to question 5. So we have question 6. Question 6 is very simple, very simple. I don't have to do it, I'll just guide you. So this one will be integrate 1 over 2 minus x squared dx. Now you just take this substitution, 2 minus x, substitute that, you see what you are going to get. You're supposed to get your final answer as 3 over 3 over 2 minus x plus c, or you get 3 into bracket 2 minus x power minus a half plus c, the two answers. So this is a simple one, you can be able to do it and see what the answer you are going to get. So be very careful with the sign, because when you don't look at the signs, you are going to get the wrong sign. So be careful so that you can get the correct answer. Question 7, we are given to integrate this function. You can see this, if you take this one to be, the reason why I'm taking this one, I don't have to explain, because for those who attended tutorial, they are aware why I'm taking this one. If you differentiate 4y, it will not give you a function in what we are differentiating, but if I differentiate whatever is inside here, I'm going to obtain a y. So this one will be du is equals to 4y dy. That way, that means du over 4y is equals to dy. And you can do now that substitution. 4y is equals to square root of u, dy you replace with d over 4y. This and this will cancel, and this one we are going to have a function of this form, 1 over power half du, which can be written as you integrate u power minus half du. And this one is a straightforward integration. You can do it and substitute back. So when you do this one, it is supposed to give you something to do with plus c, which will give you answer to 2 square root of 2y squared plus 1 plus c. Make sure you get that one as your answer. For question 8, you can take the substitution u is equals to 1 square root of x, which is the same as 1 plus x power half, du dx, or derivative of this one will be a half minus power half dx, which means this one can be written as du over x power minus a half d is equals to dx. You can do that substitution. If you do that substitution, you are going to obtain something of this sort, into bracket square root of x, you can write it as x power half dx, you replace it with 2 du into bracket x power half. X power half multiplied by x power minus a half is 1, so this one can be written as 2 into bracket u power 3 du. Very simple, very straightforward. And this one will give you into bracket power 4 divided by 4 plus c, and this one give you a half u power 4 plus c, which is the same as a half into bracket 1 plus square root of x power 4 plus c. We replace u to its value there. So these questions are, for this question you can do it with the two method. You can substitute u is equals to secant x, or you can substitute u is equals to tan x. But the easiest one is you substitute u is equals to tan x. The reason being, if you take the derivative of tan, you normally get secant squared. So du is equals to secant squared x dx. This implies du is equals to secant squared x is equals to dx. Now, if you substitute back now in our integral, our u is tan x, so we are going to have u squared. Tan you replace with u, so it will be tan squared secant squared x. Our dx now we replace it with du over secant squared x. This one and this one will cancel, so we are going to have u squared du. This is the same as u cubed over 3 plus c, and this is this 3, and this is very simple. Now we replace back u, we know it's tan x, so we are going to have tan x cubed over 3 plus c. Very simple, very simple. This question is almost similar to question 5. If you check question 1, this is the same, is almost similar to that. So you can take the substitution x power 4 over 3 minus 8, and this one will give you derivative of u will give you 3, or the derivative of this one, sorry, the derivative. So this one will be the derivative with respect to x. Then this one will give us 3 over 4 du is equals to x 1 over 3x is equals to dx. This one will give us x power 1 over 3 sine of u dx now is 3 over 4 du over x power 1 over 3. This one and this one will cancel, so we are going to have 3 over 4. We integrate sine u with respect to u. We know the integration of sine is minus cos, so this one will be 3 over 4 minus cos of u plus c. Now we can replace back what is cos, and we are going to get this one is minus 3 over 4 cos of u. We know our u is x power 3 minus 8, that one, plus c. These questions are very simple if you get used to them. The more you do, the more they become simple to understand and get how to really solve them. So that is the solution to question 10. We can look at solution to question. This is very simple, very easy. You just take rate u is equals to 5x plus 2. So this will be du is equals to 5 dx. This implies du over 5 is equals to dx. And now you can substitute cos of u du over 5. This is the same as integrating 1 over 5 cos of u with respect to du. And now we know the integration from your tables, the integration of cos is sine. This is the same as 1 over 5 sine of u plus c, which is the same as 1 over 5 sine. We know our u is 5x plus 2 plus c. In this question, if you did not have to do substitution, you could have used direct the formula for integration for cos, which is we normally write it is sine of mx divided by m. You divide by, that is, yeah, divide by m. What is attached to x, you divide by 8. You could have gotten the answer. Question 12. I will not complete this question because it's very simple. Just do this substitution here. Do that substitution, then you manipulate this function. You see if you are going to get this as your answer. Do that one, because this is very simple. I don't have to do it anyway. So manipulate your answer, do this substitution, then see if you are going to obtain that as your answer. Question 13 look easy, but I'm going to do this question because to some people might be a problem. So let u is equals to 7x plus 2. So du is equals to 7 dx. This implies du over 7 is equals to dx. I can do that substitution. 1 over u dx is du over 7. So this one can be written as 1 over 7. I take the constant out, 1 over u du. This form of a function, we have it in your tables, which it is integration of 1 over x is equals to natural logarithm of x. Also, if you have checked the solution to simple functions that I did earlier, I explained why such kind of functions that look like this have the integration is equals to x. So this one integration gives us the natural logarithm of u, which will be 1 over 7 natural logarithm of u absolute plus c. This means I just have needed to replace back. Natural logarithm of u is 7x plus 2 plus c. This is the last question, which is very simple. You check we have two functions, this and inside function. If you differentiate this function, you are going to get 2, which is not a function that we have in here. But if you differentiate the inside function, you are going to get this function here. So the best substitution you can do, it is to let u is equals to x squared plus 2. This will give us du is equals to 2x dx, which implies du is equals to x is equals to dx. This one is equals to 2 over 3 integrate u power 6. I replace now the whole of this one with u, 2x and dx I replace it with du over 2x that way. This one and this one cancels. We have 2 integrate u power 6 with respect to du, and this one give us 3 over 2 u power 7 divided by 7 plus c. And this one now we can open it to have 3 power over 14. Yeah, I think it is 3 over 14 7 plus c. And now you can substitute back your u. Your u was x plus 2, the whole of this power 7 plus c. So that is the solution to question 14, our last solution. You can go through them. If there is any question, let me know. You can text me or you can comment there. I'll come back to you and see how I can help you. Have a good day. Enjoy the mathematics.